Thanks for tuning in for another episode of Math with Mullins. Today we're going to be focusing on 9.5, our lesson on the sine and cosine ratios. If you didn't check out 9.4, I would recommend checking out that one too. That one was the tangent ratio. So today we're going to be talking about the so and the ka, if you were picking up on that. Opposite and hypotenuse and adjacent and hypotenuse. So we'll be able to use those ratios. Find the sine and cosine of angle measurements in special right triangles, like 30, 60, 90, and 45, 45, 90. Those are going to be popping up again from previous lessons in Chapter 9, and then be able to deal with real-world problems in those situations. Okay? Sine and cosine ratios are trigonomic ratios for acute angles that involve the lengths of a leg and the hypotenuse of a right triangle. So again, only works with a right triangle. And this time we're going to be focusing on different legs and the hypotenuse. Okay. Again, from here, we're going to be using opposite and hypotenuse for sine, and cosine is adjacent and hypotenuse. So the whole entire thing is so, ka, toa. So we've already done tangent, which is opposite and adjacent. Today we're doing sine and cosine. So sine is the S with the O and the H. So that's opposite from the angle and review over the hypotenuse. And then cosine is your adjacent over hypotenuse for the angle unmentioned. Okay? This is just a beautiful picture of that. If you would like to copy that down in your notes, that'd be a great idea. And then we'll move on and look at some examples. So what we're going to do is find the sines and cosines of both S and R, because S and R are the two acute angles, and then we'll write our answer as fractions and then as a decimal rounded to 4 decimal places. Typically we want 4 decimal places, that's just standard practice. So let's get to it. So we're going to do sine of S and sine of R, and then we'll do cosine S and cosine of R. Okay, remember for your sine, that is going to be opposite over hypotenuse. So if I'm looking at letter S, the opposite is 63, and hypotenuse is 65. So we're going to be using 65 a lot here. Then we can take our calculator and do 63 divided by 65. That decimal we get is 0.9692, rounded. The sine of R would be opposite over hypotenuse. So opposite is 16, hypotenuse is 65. That simplified, 16 divided by 65, 4 decimal places is 0.2462. Okay? Cosine of S. Cosine is A over H, so adjacent over hypotenuse. So the cosine of S, adjacent to S, is 16. Hypotenuse is 65, which is going to be the same thing as the sine of R, so 0.2462. And then the cosine of R is the adjacent, 63 over 65, which in this case is also the same thing as the sine of S, so 0.9692. Okay? Sine and cosine of complementary angles. This is another thing we're going to be looking at. The sine of an acute angle is equal to the cosine of its complement. So the cosine of an acute angle is equal to the sine of its complement as well. So it's almost like you're trading in and out here. So if A and B are complementary angles, meaning they're going to add up to be 90 degrees, then the following statements are true. If I would like the sine of A, I can find the cosine of 90 degrees minus A, and that'll give me B, right? Because if they're both equal to 90 degrees, whatever A is, what the leftover amount will give me B. This cosine of A is the sine of 90 degrees minus A to give me cosine of B. So whatever, if I'm using sine, I would calculate the cosine. If I'm using the cosine, I'm going to use the sine to calculate. So we're just using opposites here, okay? So what we're going to do is we're going to write sine of 56 degrees in terms of cosine. So if I want sine, then I'm going to calculate it with cosine. So I'm going to say cosine of 90 minus 56, okay? The cosine of 90 minus 56 is 34 degrees. So then I would just find that out using my calculator. Cosine of 34 is about 0.8290, okay? For cosine of 69 degrees, that means I want to find in terms of sine. So sine of 90 degrees minus 69 degrees would give me the sine of 21 degrees. So 21 times sine is 0.358. We're going to round that up to a 4. Okay? Next up, finding the values of x and y using sine and cosine. Round your answers to the nearest tenth. So, first thing we're going to do is use x and y for sine. So let's focus on sine first. For x, to find the sine, I'm going to notice that sine is opposite over hypotenuse. So I will be able to then think about how that's going to work for me. X is across from 26, so I'm going to use my sine of 26 to do opposite, which is x, over 14 hypotenuse, okay? When I find the cosine of that, cosine is adjacent, which is y, over hypotenuse, okay? And that'll be cosine of 26. I need to rewrite that guy. So sine of 26 and cosine of 26, okay? So really, the way this question was worded was a little bit tricky because it didn't say find the cosine and sine of 26. It just said solve for x and y, but we can use sine and cosine of 26 to find x and y. So let's start here with the sine of 26 is equal to x over 14. I'm going to multiply both sides by 14, cross these out, so x will be equal to 14 times the sine of 26 degrees, okay? So I take 26 degrees, find the sine of that, it's 0.4384, and then times by 14. I'm going to get a long decimal, I'm just going to round that to the nearest tenth. It'll be about 6.1 for my x, okay? For my y, that has to deal with cosine because it's adjacent to the 26. So again, multiplying both sides by 14. So I'll have y, I'm going to bring this down here to get more room, is equal to 14 times cosine of 26. Okay, so 26 cosine and then 14, 26 times cosine times 14 is about 12.6 rounded to the nearest tenth. Okay. Next up, similar situation here. Find the values of u and t using sine and cosine. So I'm still going to use the sine of 65 and the cosine of 65. Okay. So the sine of 65, that would be opposite over hypotenuse, so t over 8. And the cosine of 65 would be adjacent over hypotenuse, so that would be u over 8. Okay, multiplying both sides by 8. So 8 times the sine of 65 degrees is going to give me t, and that's going to round to about 7.3. Okay, cosine of 65 degrees, multiplying both sides by 8. So whatever 8 times cosine of 65 degrees will give me the letter u, and that one is going to round to about 3.4. Okay. Next up, we have our special triangles that says find the cosine and sine and cosine of a 45-degree angle. This only works for 90-degree right triangles. That means if I have a 45, this is a 45, 45, 45. So keep in mind, my two legs could be a number, but my hypotenuse is that number times the square root of 2. Okay, so if I want the sine of 45 degrees, that is opposite over hypotenuse, so x over x square root 2. Remember, it'd be easier to make x be the number 1 so we can solve, so let's do that. Let's say 1 over 1 times square root 2. Then I need to get rid of my square root 2 in the bottom, so that's going to give me square root 2 over 2 for my sine of 45, okay? Then for my cosine of 45 degrees, cosine is adjacent over hypotenuse, and that's still going to be the same thing because adjacent next to 45 is x, hypotenuse is still x square root 2, which I can take as 1 over 1 square root 2, and then we saw how that worked out. Square root 2 top and bottom, 2 square root 2 is my simplified version, okay? The next one we have is our 30, 60, 90. So if we build maybe that triangle, let's say like maybe 30's up here and 60, okay? According to that, my smaller side would be x, or short side would be x. My longer leg would be x square root 3, and my hypotenuse is just 2 times the leg, okay? So sine of 30 degrees would be opposite x over hypotenuse, 2x. And then if I gave x the number 1, that just is going to simplify to 1/2, okay? For my cosine of 30 degrees, cosine of 30 degrees means adjacent over hypotenuse. So x square root 3 over 2x, or square root 3 over 2, okay? Last little bit, again, angle of depression. This is the angle that a downward line of sight makes with a horizontal line. So a little bit different than yesterday. Angle of elevation is what we talked about yesterday, and that is when your angle has an upward line of sight, but now we're looking at a downward line of sight, okay? So you are skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance x you ski down the mountain to the nearest foot. So we know it's going to involve some sort of right triangle, and we'll say that's our hypotenuse. And when I'm thinking about elevation, from top to bottom is 1,200, right? 1,200 feet. The angle of depression is 21 degrees. That means my slope is 21 degrees. So what I would want to know is my sine of 21 degrees is equal to my opposite, which is here, over hypotenuse, which would be x, okay? Because it says find the distance x you ski down the mountain. So from here all the way down the mountain to here, okay? So 21 degrees sine would be opposite 1,200 over x. The first thing I want to do is multiply both sides by x to get x not on the bottom. So x times the sine of 21 degrees is equal to 1,200. Next, to solve for x, divide both sides by sine of 21 degrees. Okay, so once I do that, that's going to give me about 3,349 feet because I'm rounding to the nearest foot. Okay. Last little bit. You're skiing down a hill with an altitude of 800 feet, so we can go ahead and set that up kind of the same way. Here's 800 feet. Angle of depression is this 15 degrees. Find the distance x you ski down the hill to the nearest foot. So again, we can use sine because I'm given my opposite, which is 800. So sine of 15 degrees, opposite, which is 800, over hypotenuse x. Multiply both sides by x. So I get x times the sine of 15 degrees is equal to 800. Then divide both sides by sine of 15 degrees. Last but not least, I'm going to round to the nearest foot, which is going to give me around 3,091 feet. Okay? That'll be our last question for our last example for lesson 9.5. I hope this video helped you just kind of apply sine and cosine and get a better understanding of what it is. Thanks so much for tuning in. If it did help you, give it a thumbs up, and we will catch you next time. Have a great day.